All right, let's go through the study guide for Unit 2. The first one, I actually use Desmos, but there is a t-table, and on a test, that's all you'd have to do is a quick t-table. You know that there's going to be an asymptote at x equals 0 because the graph is undefined there, so your domain is all real numbers except x cannot equal 0. And if you have any doubts, all you have to do is take the denominator, set it not equal to 0, and solve. Divide by 4, take the square root. The range, if you look at that graph, everything is greater than 0. And then if you were to ask, is this continuous? No, it's not continuous, because you have to lift up your pen and draw a reflection on the other side of that y-axis. All right, the second problem is very similar. The graph looks a little bit different. It's been shifted down one. So we actually have a horizontal asymptote right there. And we have a vertical right there. So our domain is all real numbers, but x cannot equal 0 because that is where I am having a vertical asymptote. In here, my range is I've got positive y's, I've got negative y's. The only place I don't have a y value is along that horizontal asymptote. So y cannot equal -1. And if you notice, that's what it's being shifted down one. And is the graph continuous? Nope. All right, on to number 3. We want to solve. Well, actually, we're going to throw that one out because there's nothing to solve there. It's not set equal to a number. I probably copied and pasted that from something. If you wanted to graph it, you could graph it, but you can't solve it. So on this B, you would subtract 2. Square both sides. And you get x minus 2, or x squared minus 4x plus 4 equals x minus 2. Remember, you have to FOIL that side. Now we've got a quadratic. In order to solve a quadratic, it has to be set equal to 0. So I'm going to subtract x from both sides. 4x minus x gives me that 5x. I'm also going to add 2 to both sides. Then it looks like I can factor that. 2 numbers that multiply to 6. Add to -5 are going to be -3 and -2. And I'm going to get x equals 3 and 2. Do a quick check to make sure that you're not creating an extraneous solution. 3 minus 2 is 1. Square root is 1. Plus 2 is 3. That would match up. So that one works. Try 2. 2 minus 2 is 0. Square root of 0. 0 plus 2, 2 equals 2. So they both work. On C, x minus 3 equals -2. All I did was I subtracted 5 from both sides. And I could go ahead and square both sides and solve. but there's no point because I know that if I take the square root, I'm never going to get a negative solution or negative answer. No solution. On this one, you want to work smarter, not harder. If you notice that you're taking a square root and your answer is negative, that's never going to happen. All right, how many turning points and how many zeros? Well, it's a third degree, so there's 3 zeros. And the number of possible turning points is always 1 less. So 2 possible turning points. Maybe type the next one. I'm not writing very well with a mouse here. Because if I were typing, I'd also put in the word possible. This one, trick question. It's not written in standard form. On this one, 3 zeros, 2 possible turning points. And on C, it's going to have 2 zeros, 1 turning point. So if you see something like that, those should be actually give me questions. We're not trying to trick you or anything on that. All right, on 5, we want to complete the sentence for each of the following. Well, the first thing I notice on this one is 4x cubed equals, or minus 2x squared minus 1. It is an odd degree with a positive leading coefficient. That means my end behavior is down, up. So as x approaches infinity, f of x, which is just y, approaches infinity because it's going up. As x approaches negative infinity, f of x approaches negative infinity because my y values are going down. All right. B is also a trick question again. It's not written in standard form, so you have to look at that highest degree. It's an odd degree with a positive leading coefficient. So our end behavior is down, up. It's going to be the same answer as the one above for the same reasons. On C, that is an even degree with a negative leading coefficient. So my end behavior is down, down. So as x approaches infinity, f of x approaches negative infinity. As x approaches negative infinity, y is going to negative infinity. All right, so we want to graph this, and we want to state the zeros, and we're going to state the multiplicity. That means if they're going to be repeated or not. So if I were graphing that, what I notice right away is, hey, that's a perfect square. So 5x squared minus 4x. Well, you know what I didn't do? I did not look for a GCF. Oh my gosh. Rookie mistake. I always have to look for that GCF first. Let's factor out that x squared. 25 x squared minus 4. All right, well, it's still a difference of 2 squares. So x squared, trying to draw a 5 there, not succeeding. Oops, and I did not mean to erase my 4 there. 5x plus 2 5x minus 2. All right, so that is factored out. That x squared, you set that equal to 0. So that's actually x times x equals 0. So since we have two zeros there, x equals 0, and that is a multiplicity of 2. If you just wanted to put x equals 0, that's fine. X is also going to equal 2/5 and negative 2/5. I'm going to put a plus and a minus there. So there's actually 4 zeros there. So if I were going to graph that right there, I'm just going to call that negative 2/5. I'm just going to call that 2/5. And we've got a 0 right there. But I also know that my degree is even with a positive leading coefficient, so my end behavior is up, up. So what happens is it's going to cross, and for a double root, it just hits it and bounces off, and then goes back through. So it's going to look like that. Kind of looks like a W for Wheeler. All right, synthetic division. I have these already set up. I'm going to put negative 2 in the box. If it's paired up with an x, it's always going to be the opposite sign. My coefficients are 2, 0, negative 15, negative 9, 11, and 12. If you notice, there's no fourth degree here. That's why there's a placeholder of 0. Bring down your 2. Multiply. Add. Multiply. Add. Multiply. Add. Multiply. Add. Multiply. Add. All right, and we started with a 5th degree. Our answer is always going to be 1 degree less, so 2x to the 4th minus 4x cubed minus 7x squared plus 5x plus 1 with a remainder of positive 10. And you can put remainder 10, or you can put it 10 over the divisor, which is what I'm going to do. All right, let's do the next one. I'm going to put 5 in the box. My coefficients are 1, negative 1, negative 19, negative 3, and negative 19. So bring it down, multiply, add, multiply, add, multiply, add, multiply, and add. If you notice, I had a little bit of difficulty there. I had a black lab nudging my arm as I'm doing this. If you hear her whining, it's because she thinks I'm talking to her and I'm not petting her, which is a horrible thing to happen in her mind. So I've got x cubed plus 4x squared plus x plus 2 with a remainder of negative 9 over x minus 5. And that is my synthetic division. All right. Probably going to only do one of these where I actually multiply everything out. And I think I'm going to do C because that is the longest one. But let's go ahead and set these up. The trick on this one is if you've got a imaginary, its conjugate is also a root. So if I've got I, negative I is also a root. So I would have to FOIL x minus negative 4. Two negatives make a positive. X minus 5. X minus I. And x plus I. On B, you'd also have to remember that I plus 1, that's a plus there, would also have to be a root because that's its conjugate. So there's going to be a lot of foiling on this one. You'd have I minus 1. Whoops, let's try that again. I will tell you right now, this is a mistake of me doing this with dogs around. 1 minus, now we take that, I minus 1. Did I say 1? Totally meant to put an X there. X minus I plus 1. All right. We got it correct that time. And then you're actually going to have to multiply that trinomial times a trinomial. You should have 9 multiplications when you're done. If you've done everything correctly, everything should cancel out. I'm pretty sure this one is in your notes. All right, C. On that one, you'd also have negative 3i. And positive 2i. So you'd have x minus 3i, x minus negative 3i. X minus negative 2i, which would give you x plus 2i. And x minus 2i. I will give you the hint, and this goes for all of them. You want to multiply the conjugates together. The factors that have conjugates, multiply those together. So I'm going to get x squared plus 3x I minus 3xi, sorry about this handwriting, minus 9i squared. And then you're going to multiply the next two together. And when you do that, you're going to get x squared minus 2xi plus 2xi minus 4i squared. Remember, I squared is the same thing as negative 1. So those cancel, and you have x squared. Now let's make that x squared look a little better. X squared plus 9, because a negative times a negative is going to give me a positive. X squared plus 4. Now we get to FOIL that together one more time. And when you FOIL that together one more time, you're going to get x to the 4th plus 13x squared plus 36. And we want to write a polynomial function, so I need to put that in function notation of f of x equals. And it is already in standard form, so let's box that up. So that's how you would do those. All right, solving. I'm going to go ahead and factor this one, I think. Let's look at that GCF of x squared. And remember, when I'm solving, I'm going to set that equal to 0. So it's 0 equals. And that'll be x squared. When I factor that out, I'm going to get x minus 2. So I'm going to take each one of those factors, set them equal to 0. So I get x equals 0. There would be a multiplicity of 2 there, because it's happening twice. And x equals 2. On this one, I'm thinking about doing it with grouping. I want to make sure that negative sign sticks with the 4x squared. I'm going to factor out an x cubed here. And I'll be left with x plus 1. I'm going to factor out a 4 here. I'm sorry. Factor out a 4x. And I'll be left with x plus 1. I'm going to have x plus 1 and x cubed minus 4x. And I can't believe I did this a second time. If you notice right here, x cubed minus 4x, there's a GCF there. I should have pulled out an x. So when I do that, and I'm pulling it out right there, I'm going to be left with x plus 1 x squared minus 4. And as soon as I do that, I realize, hey, that's a difference of 2 squares. X plus 1. I said x plus 1, but I didn't write it. And that's going to be x plus 2, x minus 2. So my zeros are x equals 0, negative 1, negative 2, and positive 2. And that makes sense that I should have 4 of them, since my highest degree was 4. All right, so we want to state if the given binomial is a factor. Well, if the remainder is 0, it is a factor. Let me say that again. If the remainder is 0, it is a factor. So we're going to go ahead and do a quick divide. Bring it down, multiply, add, multiply, add, multiply, add. So that one would be a yes. That is a factor. Let's go ahead and do the next one. I've already got it set up. My coefficients are 1, negative 8, negative 1, 62, and negative 34. So bring it down, multiply, add, multiply, add, multiply now, add. Well, I'm not going to finish that. because I can already tell that would be a no. Let's do C. Negative 8 goes in the box. My coefficients are 1, 9, 14, 50, and 9. Bring it down. Multiply. Add. Multiply. Add. Multiply. It's looking like it's going to be a no. Add. Multiply. Nope, that won't work either. Let's try the next one. Bring it down. Multiply. Add. Multiply. Add. Multiply. Add. Multiply or add, which is negative 1. Nope. So it looks like only one of those worked. All right, on 11, we wanted to graph those asymptotes. Well, there's a couple ways that you could go about doing this. First of all, you look at that denominator, and x is not allowed to be 5. So we've got a vertical asymptote at 5. And if I wanted to, there's a couple different ways I can figure out that horizontal asymptote. I could go ahead and just do a quick long division, which I know everybody kind of groans at long division, but on this one, it's really not that bad. Because x only goes into x one time. Subtract that, and you're going to get 8. So if I were to rewrite that as more of a rational fraction, 8 over x plus 5 plus 1, we know that it's being shifted up 1. So you're going to have a horizontal at 1. Another way to look at that is if you look at your highest powers, in this case, x to the first power, x to the first power, x over x reduces down to 1. Okay? And that gives it to me. If for some reason you've got a higher power in your numerator than you do in your denominator, you are not going to have a horizontal asymptote. Let me say that again. If you've got a higher power in your numerator than you do in your denominator, you are not going to have a horizontal asymptote. All right. Draw a third degree function, so that would be cubic. With a negative leading coefficient. Well, I know my end behavior then is going to be, cubic would be odd. Negative, it's going to be up, down. And it should cross 3 times. Whoops. I just got hit in my arm by another black lab who is convinced I am talking about him and wants to go outside very badly. So, crosses once, twice, 3 times, ends down. All right, number 13. We want to draw a cubic that has no x-intercepts. This is a trick question because it's either going to be up, down, or down, up. So they're going to be going in opposite directions. So there is no way that you can draw something without crossing the x-axis. And in the past, I've had students, well, what about this? They draw something that looks like that. They're like, that's not crossing the x-axis. Well, it really is, because you've got an arrow there that's going to keep on continuing down. Let me do that a little bit better. Yeah. So that kind of looks like a cubic function, but that arrow means that it's going to continue go down so that it will cross. So this is impossible. Draw a quartic. That'd be a 4th degree. The way I always do that is quartic, quart, with a positive leading coefficient. So up, up. All right. So that's it on that one. Seems to have some technical issues. Just a second.